Hello and welcome to yet another tutorial on statistical techniques for data pre, post and processing. So today we will discuss about the Mann-Kendall test for trend analysis. This test will show us whether in a specific data set having multiple data points has any inherent trend or not. Because if you have trend, you can develop a model with the data set. If there is no trend within a data set, you cannot develop a model with that same data set. Okay, because the model learns from the trend of the data. If you are developing a statistical model or a deterministic model, not a conceptual model, because for conceptual models, the trend is already known, already estimated by some other governing equations, which are established with the help of experiments in lab or in nature. Okay, but in case of statistical model, where we develop the model based on the data, this type of test need to be conducted before you use that data set for model development. Although there are various different trend analysis tests available, today we will discuss about Mann-Kendall test. I have already discussed about Run's test, which is another pioneering test for trend detection. Mann-Kendall test is another trend detection test, which is or which yeah which is presently widely used in different research studies, which involves development of numerical models. Okay, so uh, so this test, Run's test, and many other tests for trend detection, I have made or making tutorials on them, and I will publish them in my YouTube channel, Mridmoy's View, uh, and also in my Hydrogeek newsletter, or maybe in my another newsletter named as Boipatra Very Short Term Course. Uh, Boipatra Very Short Term Course. So that can be found in the URL, the website boipatra.ws. Okay, never mind. So as we know that uh, any numerical model uh, has an hypothesis, which is known as null hypothesis. Uh, for this problem, the null hypothesis is the data set has no trend. That means if the null hypothesis is true, there is no trend in the data set. And the alternative hypothesis is, if the null hypothesis is incorrect, then alternative hypothesis is correct. Hence, as the null hypothesis is data set has no trend, so if null hypothesis is not correct, then data set has a trend, which will be the automatically the alternative hypothesis. Okay, so here the null hypothesis said that if the condition is not if the condition is met, then the data set has no trend. Now you will say, what is the condition? Condition is uh, either the tau, critical tau, or the critical jet is less than the current tau or current jet. Current tau, current jet means for the current problem, whatever tau I have calculated or whatever jet I have calculated, that is referred as current tau or current jet. And critical tau and critical jet is predefined and available in a table-like manner in most of the statistical textbooks and also in the internet. Later on, I will show both of them to you, but presently that this much you must know. Now, my next few slides, I will discuss what is tau, what is z, when to calculate tau, and when to calculate z. Okay. So, yeah. So, before calculating tau, our first step will be, this is the first step of Mann-Kendall test of trend detection. My first step will be to calculate the statistics S. Okay. In here, what we try to find is uh, in a group of data, that means a data set. Suppose we have a group of data. Okay, let us name it as N1 to N12. So we have total 12 number of data, right? And then we will try to analyze that each of these data is greater than or less than its or each of the other data. Generally, these data set will be a part of time series. That means all the data will be dependent on time, because this type of trend detection tests are generally applied into a time series data. Okay, like for example, yearly rainfall or monthly rainfall. Okay, so once you get the data set where there are, say for example, 12-month rainfall. Okay, you have the data of 12-month rainfall. That means how much rainfall was there in January, how much rainfall is there was there in February, March, April, May, June, until December. You can take this as average rainfall or total rainfall or peak rainfall. Whatever may be the case, you are giving the monthly rainfall data. So in 1 year, there is 12 months. So you have 12 data. Your first job will be to arrange these 12 data uh, from previous to current date. That means from January to December, you have to arrange this data if the data is mixed. Okay. So with respect to the time scale, you arrange the data chronologically from previous time scale to current time scale. If you have 50 years data, then you start from the previous most year and come to the recent most year. Right? For example, if you have data from 1950 to 2000, then 1950 will be in the top and the 2000 will be in the bottom. Okay. If it is the data is not arranged like that, you have to arrange it like that. This is the first step. But what I will say, before first step, you have to do that. Second is, as a first step, you will try to analyze each of the data with each of the other data and try to find out whether the other data is greater than or less than your current data. Okay, so that is the main thing that you must do. From if there are 12 number of data points, then you have to compare 11 times and find out that whether these 11 other data are greater than the current data or not. Whether the 11-month data is more or less from the January's data. Then you have to do it for February's data. Then you have to do it for March data, April data, May data. Compare the data of rainfall of January with the data of rainfall of all the other 11 months. Okay. Then compare the data of February with all the other data of 11 months. So as you have already compared January and February once, so you'll compare the data of the other 10-month rainfall, correct? Then come to March. Already you have compared with January and February. So remaining data are 9 months. So you'll compare with the remaining 9-month data. Then April. So April you have already compared with January, February, March data. So remaining 8-month data you compare. Each of the data with each of the other data you have to compare, whether it is greater than or less than. Now the catch. If then April data you can consider, then May, June, July, August, September, October, November, December, right? So when you are comparing the data of December, then you see you already compared the data with all the other 11 months. So practically for December you will not find any data because already you have compared, right? So what will happen is after you have compared all this data, now here very minutely, if the data is greater than your data, then put a plus. If the data is less than your data, put a minus. Okay. If the data is greater than your data, means the current month data or the month you are comparing with the other months, then plus for greater the data, minus for less the data. Suppose you are comparing with the data of January with the other 11 months, then if January data is less than any of the other months data, you will assign a minus. If not, you will assign, if greater, then if you will assign the plus. Yes. If both are equal, then you will assign 0. If they are both equal, then 0. Correct? So, and also this type of test, in this type of test, generally, if you have any data which is exactly same as the other data, then those data is removed from the data set initially. After the final step, you can include them. I will talk. I will discuss about this later on. Okay. So for now, if greater plus, if less than it minus. Say if equal, then you will give a 0. Clear? After then count how many number of plus you have got and how many number of minus you have got. So number of plus you have got, you write it here. Number of minus you have got, you write it here. Okay, so this expression basically changed to number of plus minus number of minus, okay, equals to S. So S is actually the number of plus minus number of minus. Okay, so don't take the absolute value. If it is comes in minus, suppose number of plus is less than number of minus, then certainly S will be negative. Let it be so. There is no problem with that. S may be positive, S may be negative, S may be 0 also. No problem with that. Once you have calculated your S, the next step is check whether your total number of data in your data set is less than 30 or not. Okay, so you have 12-month data, so it is certainly less than 30. Okay, so you will find the value of tau that I have mentioned in previously. I think you remember. This tau is also known as Kendall's tau. Okay, now how you can calculate tau or Kendall's tau? This is 2 into S. S is that S that you have calculated in the previous slide. N is total number of data in the data set. For this case, it is 12. This N is same, 12. So this become 2S by 12, 12 minus 1. Now S value you will calculate by deducting the number of minuses from the number of pluses, and then you will put it. If S is negative, put it as negative. If S is positive, put it as positive. If S is 0, then you can easily understood that this will become 0. Correct? Now you have calculated Kendall's tau. Now you have to find the critical value of tau from the table. There is a pre-made table where uh, for each of the level of significance, the critical value of tau is given. I will show the table later on. So if your tau, that means the calculated tau, is greater than the critical tau, then the null hypothesis will be rejected, and it will mean, or it will imply, that there is a trend in your data set. And certainly, if the null hypothesis is not rejected, that means critical tau is more than your tau or the current tau, then there is no trend. So you cannot develop a model with that data set. So this tau approach will be for a data set which have a less than 30 number of data point. Okay, if you have more than 30 number of data point, then what you will do is you have to calculate the value of set. Here also you have to use the S, and you have to calculate the variance of S with the help of this formula. Here n is total number of data points, and this is the formula. If there is no ties, that means if there is no two data with same value, then you will use this. If there is a tie, then the calculation for variance will be like this. That means this part plus this part. Okay, and this TP is the how many number of tied data is there. If there are two number of data which is equal to each other, then T will be 2. If there is 3 number of data which has the same value, then T will be 3, and so on. You just check that just the n, the total number of data point, is replaced by the total number of data which are equal. This is what they have done and nothing else. TP means T is the number of data points which are tied, which have same value, and P is the pth group of equal values. This is nothing, don't get confused or worried. P said that how many group of ties is there. Okay, but in reality, if there are 3 number of ties, that is 3 data points which has exactly same values, then your T will be 3. That is the thing. Okay, and accordingly variance will be calculated, and then you put it here. So for example, if I ignore that there is no tie, then you will calculate the variance of S like this. Okay, now another point. If S is greater than 0, then you will apply this formula, S minus 1. If S is greater than 0, you will apply this formula. Okay, S minus 1 divided by square root of variances. Variances you will get from here. And if S is less than 0, then you will apply this formula. S plus 1 by square root of variances. Variances you will get from there, here. Same variances. Only difference is if S is greater than 0, use a minus. If S is less than 0, use a plus. That is the difference and nothing else. However, if S is equals to 0, then your Z will be 0. Mind it. I have said S, for some S can be equals to 0. So for in those cases, Z will be 0 also. And remember, Z if greater than 0, after calculating, if you find a positive set and it is more than your critical set, then it signifies a, or it implies a upward trend, and otherwise downward trend. Matlab, if it is a negative Z, then it is a downward trend. Yeah. Another point is when you will conclude that your data has a trend or not. If you have to calculate Z, if your data set is more than 30, then you have to calculate Z, which is also known as standard normal deviate. So when to say that there is a trend with the help of Z score, and when to say there is no trend with the help of Z score. So this Z is also known as Z score. Okay, so like that. So let us see. So here also there will be a critical value table. It is very easily available in the any statistical textbooks or in internet. It is known as standard table of standard normal deviate Z. Sometimes it is also referred as critical table for critical value of Z. Correct. So that is the way. So first thing is how to calculate find out the critical value of Z. Now, it is not difficult. So first you decide for which level of significance you will find the critical value of Z. Okay. So for example, if I say I will pick up 5% significance, the level of significance will be 5%. Correct. Significance is referred or denoted as alpha. So then your next step will be to calculate this one, 1 minus alpha divided by 2. Okay, because generally when you are using Z score, it will be a two-tailed test. Okay, and when you are using tau, it will be a single-tailed test. Okay, so well, let us see. So two-tailed test. So for if I use alpha is equal to 5%, then what happens? You will divide 1 minus 0.05 divided by 2. Correct? So it will come around, I think, 0.95 divided by 2, which will be around 0.47. Like that. Around 0.47. Okay. Now, in your Z table, the table for critical value of Z, here in the header of your column and also for your rows, the table will have column and rows also, and for each column there will be a number as a header. Generally it will start from a lower value and increase towards for your column header, it will increase from left to right, and for the row header it will increase from top to bottom. So the column header will start from 0 point something, then 0 point something, then it will be so on, and this will also start from 0, then some 0.01 like this it will come, and here lots of numerical values will be given. So you have to find out this 0.47 from the body of the table. Lots of values will be there. From the body of the table, you have to find out your value 0.47. Generally, if you go symmetrically from top to bottom, okay, top to bottom, if you go, you will find this 0.0, then 0.1 will come, then 2 will come, then 3 will come. So top to bottom in a descending order, sorry, ascending order, the values will be written. So generally, if you go through this top to bottom approach, you will find maybe in the fourth row and sixth or seventh column, the 0.47 value will be there. If this 0.47 value cannot be found, then pick the nearest value of all of them. Now, once you find the value 0.47, just move topward, upward, and see what is the value in the column header, and then move leftward and see what is the value in the row header. Okay, and then add both of them. So if this value is 0.3 and this value is 0.07, you add 0.3 plus 0.07, this will be 0.37, which will be equals to your critical Z. Correct? And if your Z, the current Z score that you have calculated with the help of this formula, is more than your critical Z, then there is a trend, otherwise no trend. Now, if your Z is minus, remember, negative Z, then if your it must outclass your the critical Z in the negative manner. That means your critical Z or your Z is need to be more negative compared to your critical Z. If your critical Z is positive, your Z is negative, then very easily you can say there is a trend. If both are negative, then what will happen? Your Z must be more negative than your negative critical Z. If that is the case, then there is a trend. If that is not the case, then there is no trend. So if you have a positive Z and positive critical Z and a positive Z score that you have calculated for your data, then your positive Z must be greater than critical Z. Then there is a trend. If not, no trend. Correct? Again, if you have a negative Z and you have a negative critical Z as well, then your negative Z must be more negative compared to the critical Z. Suppose the critical Z is minus 0.47, correct? And your Z, that means the Z you have scored with this formula, is minus 0.81. Okay, then your data has a trend. Otherwise, your data has no trend. So it is clear how to find trend with Z value. Remember, Z value comes into play if and only if your number of data in your data set is more than 30. If not, just calculate the tau, and in tau also there will be a table. If your tau is more than the critical tau, then it is your data set has a trend. If not, your data set has no trend. So it is as important as that. I have already discussed about this. So now I will show you first I will show you the table of critical Z and critical tau, and then I will show you an Excel sheet by which you can calculate whether there is a trend or not in your data set straight away with the help of Excel. Okay, so let us go to the second part now. So This is the critical value table for Kendall's tau. You see, the significance value alpha is given here and sample size is given here. In our case, we have a 12, n is equals to 12 because there are 12 data point in our data set. So sample size is 12, but here you see there is no 12. So you have to just interpolate. If for, and I want the critical value of Kendall's tau for a significance level of 5%, that is alpha is equals to 0.05. So for that, you see, for sample size 10, we have the value as 0.46. And for sample size 15, we have a value of 0.35. You just interpolate it to find the value for 12. Okay, so by interpolation, I think you know, just for 10 sample size, we have 0.46 as the value. So what will the value if we have a sample size 12? Just unitary method you can find out, or you can use the interpolation method by uh, I think better you use the unitary method, right? Okay, so 10 for 10 0.46. So for 12, how much it will be? 0.46 by 10 in multiplied by 12. That will give you the critical value of Kendall's tau. Next one is sorry, the next one will be your Z score. So for Z score, you see, for the Z score, will let me see. For Z score, we have a value. Let me show you the table, critical Z score table. Let's just wait. So this is the critical value table for positive Z score. You see, here is the table. So as I described in the presentation, you have to find the 0.47. Okay, because you are talking about, you are trying to find out the Z score for a level of significance 5%. So for that, use the formula 1 minus alpha divided by 2. That means 1 minus 0.05 divided by 2. So it comes to 0.95 divided by 2, which is equal to more or less 0.46. Right? So this positive value of Z score start from 0.5. So maybe it is not there. Okay, let me go with the negative scores. I think here we can get the 0.47 somehow. Yeah, this is the table, I think. You see 0.47. I say that if you cannot find 0.47, use the nearest of them. So yeah, here it is 0.4746. You see nearest, oh no, this is 0.47, not 0.47. So you have to find it. Let me see where I can find it. 0.4545, yeah, here. 0.47, I think 0.472 is more nearer. right? So 0.432. So now move towards the header of the column. It is 0.07. Header of the row, minus 0. So you just add minus 0 plus 0.07. So it will come as minus 0 plus 0.07. It will come around 0.07 in a minus, right? So what will be the result? Your Z score, that the calculated Z score for your data must be more negative uh, to the negative value of Z. In our case, it is a negative value of Z. So it will be the critical value of Z is, you see, 0.07, sorry, minus 0 plus 0.07. So it will be not critical, not negative, it will be positive. 0.07 is the critical Z value. And if your score is more positive than this, then it is your data set show a trend. If it is not, if it is less than that, then your data set has no trend, right? Now, if this is minus 0.07, your critical value of Z is minus 0.07. If that is the case, then your Z score, the calculated Z score, must be more negative to your negative critical Z score. It must be around minus 0.17 or minus 0.18, like this. If that is the case, then your data set has a trend. If it is positive, or if it is less negative than the negative critical Z score, then it doesn't show any trend. Okay, so with this, let us move to the next part. Okay, so let us see the Excel sheet that I have developed for demonstrating this trend detection method, Mann-Kendall. Here what I have written is the sample data set, a rainfall data set of 12 data points. You can find it from 5. First data is of January, last data is of December. Okay. Second, what I have done is, just you see, I have deducted the first point. I have said each of the data must be compared with each of the other data. Okay. Now, before that, I have arranged these data points with respect to its time series. The January data comes at the top point, December data comes at the last point. That is done. Now what I am doing is, I have to compare each data with each of the other data. Okay, so what I have done, I have deducted the first data from all the other data of this data set. So you see the formula A3 minus A2. That means A3 is this one. I have deducted it from the first data, A2, and so on. Okay, so this is for the first data. So as you see, this 10, 20, all are positive, which indicate they are greater than my first data. So I have given a plus sign. If it is negative, then I have given a minus sign, like is this case. Here I have deducted the second data from all the other data. As the comparison between the first and second data is already done, so I have not deducted my first data or my second data from the first data, right? Because already I have deducted it, compared this first and second. So here I have start from the third data and deducted the second data from the third, fourth, fifth, sixth, and so on. And the results are given here. If the results are positive, then a plus sign is given. If the results are negative, like this case, my last data and my second data, uh, you see my second data is greater than my last data, so a minus sign is given. Okay, so this is the way I have done. So in this column I have deducted all the other data. Sorry, I have deducted my third data from all the other data except the first two data. Third data from all the other data, all these data except 5 and 15, which are my first two data. So if it is positive, I have given plus. If it is negative, I have given minus. Clear? So this is what we have done, and accordingly we have made the Excel. Okay, here you see it is already taken. So all these column are like that. The first column is about first data deducted from all the other data. Second column is the second data deducted from all the other data. Then third data, then fourth data, then fifth data till your 11th data. And I have said 12th data has no one to compare because already all the data have been compared with it. So 12, there is no 12 data. Other than that, up to 11th, we have done this same thing. Okay. So next what we have done, we have counted how many number of pluses I am getting. You see, for the first column, I am getting 11 pluses. For the second column, I am getting 8, then 6, then 3, then no pluses, 0, 0, 0, 0, 0. And in case of minuses, number of minuses, for first column 0, second column 1, third column 2, then 4, 7, 6, 5, 4, 3, 2, 1. Okay, so these are all of my number of pluses and minuses. Then in the here you see I have counted all the pluses, 11 plus 8 plus 6 plus 3. That means it comes to 19 plus 6, 25 plus 3, 28. So here I have written the 28. Number of minuses 35. Same manner. 1 plus 2 plus 4 plus 7, then plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. So 35. Then I have found out the value of S. Okay. So what is the value of S? The value of S is that I have already discussed. The value of S. This is the value of S. How to calculate? Number of pluses minus number of minuses. No, not take the absolute value. If it is negative, negative. In our case, S is negative. So we have used negative. Okay. If S is positive, we would have used positive. So in our case, S is minus 7. So as I have only 12 number of data points, so as I've already discussed, if there are less than 30, if in your data set number of data is less than 30, as is our case, you will use tau. You will calculate tau. So I have calculated tau. What is the formula of tau? This is the formula of tau, 2s divided by n into n minus 1. N is total number of data points, so I have given 12, right? So in this way, I have calculated tau. AC is, you see, AC is minus 7. So 2s, 2 into minus 7 divided by 12 into 12 minus 1. That means 12 into 11. So it has come into a negative value. Certainly it will come to a negative value because S is minus. So what is the negative value? Minus 0.11. So accordingly what happened is we have a tau, negative tau. Now we have found out the critical tau for a level of significance 5%, and then there in that table straight away they give the tau, the critical tau with respect to its level of significance as per the number of data points you have. So the critical tau was less than our tau, so as a result there is a trend, it was detected. If your data points was more than 12, then I would have called I would have used z value. I would have calculated our z value. So if z is if AC is positive, which is not our case, our AC is negative, there is a formula for that. This is it. If S is positive, then S minus 1 divided by variance S. If not negative, S plus 1 divided by square root of variance S. If 0, Z is 0. Variance S formula is this. So all this formula was encoded here. You see, if the S is positive, the value of Z will be minus 0.55. If the S is negative, the value of Z will be minus 0.41. So as our S is minus, so I have to take the Z value as minus 0.41. Variance S is calculated beforehand. So if our AC Z is minus 0.41, then I have to find out the critical value of Z. And if this critical value of Z is negative, then our Z must be more negative than that. If our Z critical value of Z is positive, then our Z must be more positive than that. So as our critical value of Z has come to be 1.92, however our Z is negative minus 0.41, so it shows that there is no trend. But it is an incorrect decision because in our case number of data point is less than 30, so I should not use the value of Z to decide whether we have a trend or not. So this is the proof that if your data point is less than 30, don't use. If your number of data point is less than 30, don't use the z-score method, use the tau method. And if your data point has more than 30, then use the z-score. So here you see the z-score has detected the trend incorrectly, because in our case there is only 12 number of data points, so it is incorrectly detected. So I have to ignore the detection of z-score, and I have to go with the detection of tau, where it has correctly detected the trend as available. There is a trend in this data set. Okay, so this much for today. So if you like this tutorial, kindly like, share and subscribe to my YouTube channel and also my newsletter hydrogeek.substack.com. And also you can visit the my website, where you can find many such courses on statistics as well as bio-inspired optimization techniques. So the website, the address to the website is boipatro.ws, www.boipatro, BAIPATRA.ws. Or you can straight away scan this QR code and visit my YouTube channel, subscribe there. You will get lots of free tutorials, startup ideas, internships, and many other career developmental opportunities in water and power engineering. Okay, so goodbye for now. See you in the next video. Okay, so that much for the Mann-Kendall test for trend analysis, or rather trend detection. I think if you can apply this test for your research problems, then I will think that I am successful in showing you the way you have to conduct the Mann-Kendall test for trend detection. It's a very simple test, but you must do this test or any other trend detection test for your dataset before developing a model with that dataset. Okay, so if you like this tutorial, share it with your friends. And for now, it is goodbye, but till the next tutorial. Thank you and good night. Goodbye and good night. Do you want to know about artificial neural network? A free lecture on artificial neural network can be accessed by scanning the QR code as shown in the video. Just scan the QR code and you will find the tutorial on artificial neural network. Only the basic of artificial neural network was discussed here. For more details, you need to go through my other tutorials related to this ANN techniques. And in this short tutorial, although not short, it is nearly 1 hour long. Within this time, I have tried to introduce the basic concepts only.